Physics team. This is my first screencast recording, so welcome. It's going to be amazing. So I know I've been gone, and I will continue to be gone, but I'm going to leave you a video or two so we can at least get through torque and how we calculate that, and then getting into angular momentum. So last chapter we were talking about torque and talked about how you could find the direction of it using the right-hand rule, which is true, but sometimes you're given torque in unit vector form, and so we need to figure out how to deal with that. So that's where cross products come into play. Now, just as a review, we've already done dot products. Okay, so these are also called scalar products, which gives you an idea of what they produce, which is a scalar, and cross products are also called vector products. So if you remember dot products, you took a vector times a vector and got a scalar product. Spoiler, cross products are going to give you a vector product. So for dot products, we took A dot B, whatever our vectors are. And when we did that, so we multiplied the magnitude of each vector, the components that were in the same direction, and then just added it together to get your scalar product. Now, when we did these, the order of our vector didn't matter, and I'll show you an example next. So for your math nerds, this is a commutative equation, I guess. So we use this when we did work. So work on your equation sheet, it lists work as the dot product between force and distance. So for example, if force equals 3I hat, 6J hat newtons, and our distance is negative 6I hat, 4J hat meters, well, then we're going to multiply the magnitude of the vector in each direction. So multiply our I hats, multiply our J hats, add them up. So our work will be 3 times negative 6 plus our J hat directions, negative 18, 24, ta-da, scalar product. Now, it doesn't matter if we did our J hats first. So even if this was, our I's and J's were reversed, you'd still just be adding them together and you'd still get 6 joules as an answer. And one other thing I want to add, you get the largest magnitude of your dot product or the work. So our biggest magnitude. Okay, so if we have an object that we want to do work on, say this box, my force and the distance it moved to do the most work, they should be parallel. So it's moving this distance, my force should be parallel to that. Okay, if that's at any angle that's not just straight parallel, there isn't as much work done. And we could see that. So the biggest magnitude when vectors are parallel. So the force and distance in the same direction. And we could also calculate it, magnitude of force, magnitude of distance, times the cosine of the angle between them. So when that angle is 0, then that's when we have the most amount of work done. Okay, I'm going to stop the video for now. I don't know if I'll be able to merge them together or if you'll just have this random little video, but I want to make sure this is working. So I'll either be back or see you in the next video. We'll see.